Hi my dear 8th standard students, welcome to our science class. The last two class where we discussed about the measurement, the types of clocks and the base quantities from your textbook. So today we are going to learn a new chapter. The chapter name is the matter around us. So today we are going to learn about a new chapter and also from the new topic. So matter around us. In this world, in this universe, all are made up of some kinds of particles. So that particles are made up of from a single atom. So in this atom normally have three objects. One is in a positive ions, negative ions and neutrally charged, or is called in a proton, electron and neutron. Everything we can see everything in the world, and we can see a lot of object from around us, the particle. The particles are classified from the properties. So in these properties are classified into the three states. One is solid, liquid and gas. So solid, liquid and gas. Solid particles or solid objects are classified from their states of properties, and also it can be different from the objects of liquid and gas molecules. Solid properties. Why we are called some of the objects are in solid? For example, in our home, like table, chair, washing machine, TV, remote, mobile phone, these are the kinds of solid object. And also milk, fruit juice, petrol, diesel, kerosene, and this kind of object are called in liquid stage. Same time, in our daily life we are breathing air molecules, oxygen, and also we are releasing air one, carbon dioxide. So these kinds of the particles are called in gaseous molecule. So why it's are having a particular object, solid, liquid and gas, from their physical properties and also the chemical properties, they are classified from solid, liquid and gas. Okay, they are classified from solid, liquid and gases. Each and every object are made up of from a single atom. So in this atom have defined as in group of molecules, ions and compounds. Today we are going to learn elements. Elements, symbol of elements and also the types of elements. And elements where everything we can see, and also it is one of building blocks of matter. So matter it consists the three states. One is solid, liquid and gas. In these types of states, element is the building blocks of matter and also the sum of the energy. So elements, from this textbook, the elements is defined as is a pure substance that cannot be broken or down by the external force. So element is a pure substance, cannot be broken down by the same kinds of physical properties, and also it has some of the simple and types. So symbols of element have to classify four: Greek symbol, alchemist symbol, Dalton symbols and Berzelius symbol. So types of elements have the three types. One is metals, non-metals and metalloid. We are going to learn the first one. Symbols of element. So symbols of element classified from the four types. First one, Greek symbol. Second one, alchemist symbol. Third one, Dalton symbol. The fourth one, Berzelius symbol. Berzelius symbols. And the Berzelius symbols are denoted from the present symbols of in our chemistry world. So Berzelius symbols is denoted from our present symbols formation. So Greek symbols, alchemist symbols, Dalton symbols and Berzelius symbols. Before that, what is the simple? Anyone can say about the simple? Simple means what? So simple is denote some meaning from the particular region. So simples denote from some meaning from a particular region. For example, we denote the mathematical rules like plus, minus, division and multiplication. So this is the one kinds of simple from we are using in our mathematical rule: plus, minus, division and multiplication. So what is the plus? Plus is the add of some two number. So it denotes to be add some two numbers. The minus we can easily subtract from the two numbers. The minus is denote we can subtract from the two number. So division we can divide the two number, and also the multiplications value. So it denotes some meaning of some value. So it denotes some meanings of the some value from your mathematical rules. So in this way in chemistry a symbol is denotes what's that. So simple, the number of elements are using in the word is a shortened form called in simple. So number of elements is represented, a shortened form is called a simple. So like before that, what is an element? So element we have in around 118 elements are there. So we have around 118 elements are there. 118 elements are we have normally. So normally we have 118 element. So in this element classified into two, 94 and 26. So in these types of elements are classified into two, 94 elements and 26 elements. So 94 elements are called in natural elements and the 26 are called in artificial elements. So from this element 94s are we are using in commonly hydrogen, oxygen and then boron, silicon, carbon dioxide and everything. Here the 26 are only used for in artificially. So artificially means it can be only used the properties of in laboratories from the chemistry, the physics and also the science. In commonly in science we have used in the properties for 26 are only in how much of element we have? 118. In this 118 elements are classified into two. What's that? 94 and 26. So 94 is called as natural element, the remaining 26 called as artificial element. So 94 we are using in a common word. So 94 we are using in our daily life like oxygen, hydrogen, carbon, nitrogen, aluminium, boron, silicon and everything. 26 only we are using in the laboratory tests. Okay. Symbols of element. First one, Greek symbols. So Greek symbol is in the form of geometrical shape. It's represented 4 elements such that water, air, third one fire, and the fourth one water, air, fire, and the fourth one earth. So Greek symbol from the ancient method, where we use from the ancient method the Greek name, the Greek symbol is represented the 4 elements to be surrounded as one is water, air, fire and earth. Next one, alchemist symbol and Dalton symbol. Both tools are not following in our present system, but John Dalton was invented from the symbol Dalton symbol in 1808. The symbol was invented from the scientist, English scientist John Dalton in the year of 1808. It's denoted, it's very difficult to find out. So what is the symbol of elements are present in the variation. So what is the elements are present in the condition. That is the way the alchemist symbols and John Dalton symbols was neglected from our science. From this way the Dalton symbol was followed from the Berzelius symbols. The scientist John Jacob Berzelius was invented the symbols in 1813. It is also very difficult to find out the symbols of element. So in this variation our present system, so in this variation In this variation, our present system following from the simples, Berzelius world. So Berzelius simples is a representation that the system it's denote the elements are present in their alphabetical order. So from the system the following symbols are given your textbook page number 95 and 96. So go through your textbook page number 95, 96 clearly. So go through your textbook the page number of 95 and 96. So we will move the next one. The next one is the types of element. So types of element it's classified 3: metal, non-metal and metalloids. Next topic is types of element. So types of element are classified into 3. First one metals, non-metal and metalloids. So first one metals, non-metals and metalloids. So metal from the periodic table elements 118 elements are we have from the periodic tables. The metal types of elements are we are using in our daily life. 1 copper, iron, silver, gold, mercury, copper, iron, silver, gold, mercury. These kinds of metals are we are using in our daily life. So commonly metals have some physical properties. They are commonly metals have some physical properties. That's are one is metals are very hard. So we know that commonly metals are very hard type. Copper have a hard type materials. Iron it's also a hard types of materials. Silver also the hard one. The next one, metals are looking very shiny. So metals are look like very shiny particles. So a third one, metals are having a high density. Metals are having a high density value. Fourth one, metals are have a high melting point, also a high boiling point. Fifth one, metals are very ductility. So first one, metals are the physical properties very hard. Second one, metals are looking like shiny particle. Third one, metals are high density value. The fourth one, metals have high melting point and high boiling point. High melting point and high boiling point. Fifth one, metals are ductility properties. Sixth one, metals are the malleability function. So this is the physical properties of metal. It's very hard. It look like very shiny. It has a high density value. Fourth one, it have high melting point and also high boiling point. The fifth one, metals are very ductility particles. So ductility means it's one of the flexible value. So it can be easily flexible to make a one shape. The sixth one, it have the malleability function. So malleability means it can be hammered to very thin sheet. The malleability means can be pressed easily. So pressed by easily. So this is the physical properties of the metals. So from these elements of metal, copper, iron, silver, gold, mercury, aluminum, etc. So these kinds of elements are using in our daily life. For example, the use of metal, the first one iron. Iron is used for making bridges and thin making in a building blocks of material and engine parts, etc. Copper is used for electrical wire and also it making coins and statue. Silver and gold. These two elements are normally used in a jewelry, making a jewelry items. And also silver, gold for commonly used in our jewelry shop. Mercury is used for in thermometers and barometers. You know that thermometer, where it's used in a thermometer, it's a clinical apparatus and it's used to measure a body temperature. Okay, these are the uses of metal. So elements of the metals have the copper, iron, silver, gold, mercury, aluminum. So they have some physical properties. That's all. It's very hard. It's looking very shiny. It's have a high density point and also a high melting point, boiling point. The special characteristics of the metal have the ductility function and malleability function. So ductility means to be flexible easily and the malleability means can be pressed easily by our arms. So these are the properties and uses of element. Next one is non-metals. The non-metals are hydrogen, oxygen, nitrogen, potassium, sulfur, diamond and etc. So from their physical properties is different from the metals types of physical properties. So metals have a hard type, look like very shiny, they have the high density value and they has high melting and also high boiling point. So from these types of the properties, non-metals are entirely different from the metals value. So non-metals are have hydrogen, oxygen, potassium, nitrogen, sulfur and diamond etc. So we have lot of non-metals elements. In your textbook you have give the some of the non-metals elements: hydrogen, oxygen, nitrogen, potassium, sulfur and diamond. So diamond, the uses of the non-metals. So diamond is one of the non-metal categories and is used for making a jewelry item and also it is the use of cutting and grinding equipments. Then hydrogen. So hydrogen is used for a rocket fuel and hydrogen flame is used for making cutting and welding purpose. Sulfur. So sulfur is used in the manufacturing of gunpowder. So sulfur is used in the manufacturing of gunpowder and also is used for in vulcanization of rubber process. So potassium and the remaining one, the oxygen, nitrogen, these are having some of the non-elements. These are the non-elements metal. So this is the physical properties and uses of non-metal. From this chapter we have seen the properties of metals and non-metals. The remaining chapter we will see in the next class. Thank you students.